So as you can see, our topic is factoring integers. And we need to know what they mean. So let's start with easier one. We have two words, factoring integers. So we're going to talk about what factoring is and what integers are. First of all, anybody know what integers are? Who remembers what integers are? Yes, sir. John? Huh? Yeah, numbers, but integers are kind of specific because like 3.5, is that an integer? So you see, you can't just say numbers. And which numbers are you talking about? Yes, sir.
Positive and negative numbers.
Positive and negative numbers. Okay. So then what about negative 5.7? That's not an integer, is it? So you can't really say positive or negative numbers. Yeah, Elizabeth? Whole numbers? Okay, whole numbers, do they include negatives? No, they don't. They're all positive. Can somebody list them? Yes, sir. Sure. Yes, these are positive and negative whole numbers. You're right. Now, what does a whole number look like? They don't have any decimals or fractions. So who could just kind of tell me? Give me the list. Like, we go with 0, what? 1, 2, 3, 4, and so on. And what about all the negatives? Yeah, negatives is also here. Right here. Aren't these integers? So integers are like 0, 1, 2, 3 forever, and then the other way, negative 1, negative 2, negative 3 forever, right? These are integers. Okay, and we're going to talk about factoring in a minute. Does anybody already know or have any guess what factoring means? What? Or like factor or something? Yeah.
It's like, well, I can't really explain it, but like, it's like, so, if you have like 49, and then like the factor is going to be 7 and 7.
Very good. Okay, very good. So you have the idea. Yeah, it's one of those things. It's not really easy to really explain, but you have the right idea. So, for example, when you write 56 as a product, for example, can somebody tell me, is there a way to write 56 as a product? Meaning, what does product mean? It means using what operation? Multiplication. Is there a way to write or represent 56? Yeah, Judy. 8 times 7. That's exactly right. Is that the only way? That's the one I actually chose. Is there any other way to write? Are there any other ways to write 56 as a product other than 8 times 7? Yeah. 56 times. Okay, that's one of them. Actually, I have that one too. Good. Okay. Or any other way? Yes. Yes, sir? 4 times 14, sure. And then, what about negative 4 times negative 14? Does that work too? What about negative 8 times negative 7? 2 times 2 times 2 times 7, does that work too? Yeah. Okay. So when you write 56 as like product of these numbers, this is what we call, you have factor 56. Okay. In other words, when you factor, what does that mean? You write the number as a? As a? Anybody? As multiplication as a? No, product. No, 56 is the most simplified way of writing 56, right? But when you write as a product, as a multiplication of 2 numbers or 3 numbers or something, then you have factor that number. That's what factoring means. Okay? And what do we call these numbers? Oops. Like negative 4, negative 14, 8 and 7. What do we call these? 8, 7, 1, 56, 4 and 14, 2, 2, 2 and 7. These are called the factors. Okay, so that's why it's called factored, right? And these numbers that make up the product, right? The numbers that you're multiplying to get like 56, these small numbers, these numbers are the factors of 56. Does that make sense? So we need to understand what they mean. We're going to kind of have to start with what they mean by factoring and integers and so forth. Are you okay so far? Any question? What about, could I write 56 as half times 112? Isn't that still 56? Yeah. So have I still, if I write half times 112, is that still factored? Yeah. But in this book, unless we say otherwise, we usually want them to be, all the factors to be what? We want all the factors to be integers, okay? Unless I say otherwise. Okay, in this book, when they ask you to factor, they mean they want you to factor using integers. Is that okay? So yes, since even though that's still, factored form, we don't want to use integers unless we say otherwise. Is that okay? So if they don't say anything, just use integers. So a little bit of caution there. So let's do an example 1. You may see something like this on your homework tonight. It says give all positive factors of 42. Now notice what it says. It didn't say just any factors. It says give positive factors. And again, when I say factors without anything, I mean integral factors, right? Factors that are made up of integers. So let's do this one together. Again, factors are those numbers that make, when you multiply number times another number, you get 42, right? So let's do them by pairs. What's the easiest pair that you could come up with? What times what gives you 42? Because those will be 2 factors of 42, right? Anybody? What's the easiest one? Thomas? 42 times 1. Yeah, 42 times 1. So this is what I'm thinking in my head. You see what I mean? I'm kind of thinking as pairs like this. 1 times 42. So let's do this systematically so we don't miss any of these. What's the next one? Yes?
2 times 21.
Yeah, 2 times 21, right? You're asking yourself, well, 2 times what gives you 42 is 21. Now, how did you know 2 goes into 42, by the way? Is there a rule? Yeah.
42 was even.
Yeah, if you have an even number, right, we know that 2 must go in, right? You give me any even number, I could tell you that 2 will have to go into that number, okay? That's the rule, right? So 42 is an even number. I know that 2 goes in, right? How many times does it go in? How many times? 42 goes into 42 how many times? How many times does 2 go into 42, guys? 21. That's why we have 21 here. Hello. Okay. Okay, what's the next number that goes? 1 goes into 42, obviously. That's the obvious one. That's a freebie. 2 goes into, of course, 42 21 times. What then goes into 42? Next number. 1, 2, 3, 4, 5, 6. Who haven't I called today? I haven't called Anais.
14.
You want to jump into 14 right now? Let's do this in order.
3.
3 goes into. Oh, I see. 3 goes into 14 times. I see what you mean. You're right. Exactly right. You see how I do this kind of in order? So I don't mess up, right? Because I don't want to skip like one of these. Because it says give all, right? Factors. I don't want to skip any of the factors. Cameron? Oh, you know the next one? Okay. 6 times 7. You're right. And then 7 times it's kind of the same pair. So when they say give all positive factors, you just have to list them. And you don't list the same ones again. You know what I mean? So what are all the factors of 42? In other words, what goes into 42? Basically, that's what they're asking. You know what I'm talking about? What goes into 42? Why do we do all this work? Well, look, anybody? Can somebody? So we have actually figured out every integer that goes into 42. Does anybody know what they are?
Oh.
Yeah. 1, 2, 3.
42, 21.
Yeah. 1, 2, 3, 6, 7, 14, 21, and 42. That's it. Yeah, you could just list them. That's what they want, right? It says, so you see how I have this in bubble? That means that's what I'm thinking in my head, right? That's my work. So here's my answer. When they say give all positive factors of 42, then you just list all the number that goes into 42, or integers that goes into 42. And you see how easy it is? Once you do this by pair, you just list all the numbers. Look, does 1 go into 42, guys?
Yeah.
What about 2?
Yeah.
Yeah. What about 3?
Yeah.
6, 7, 14, 21,
Yep.
42? Are there any other positive integer that goes into 42 other than the ones I listed? No, so we're done. Does that make sense? You can kind of check. Look, what's 1 times 42? What's 2 times 21? You see how you could check like that? What's 3 times 14? What about 6 times 7? There you go. Does that make sense? By the way, how did you guys know that 3 goes into 46? I mean 42.
Oh.
Is there a rule for 3? We had a rule for 2. Is there a rule for 3? Like, how would you know whether or not 3 will go into any number? Because there's a rule, I think. Does anybody remember? Aaron? What do you add? What do you call those? If we add the number? What do you mean number?
Oh, I don't know.
It's not quite number. Because if you have 42, what are you adding? You're adding 4 and 2. What do you call 4 and 2? Those are called the digits. If you add the digits of the number, and what? So what? Just add it?
Oh.
Raise your hand if you know. Yes, Andrew?
If You add the digits of the number, and then that number that you get is divisible by 3.
That's right. If that number you get is divisible by 3, I have it over here. The rules were multiples of 3. The sum of the digits, if that sum of the digit is divisible by 3, then the whole number is divisible by 3. Did you guys know that? The sum of the digits is divisible by 3, then that whole number is divisible by 3. So did you guys know that 111 is divisible by 3? Did you know that? 1 times 1, 1, 1, right? What's 1 plus 1 plus 1?
3.
3. So 111 is divisible by 3. Did you guys know that?
Yeah.
Yeah. It's pretty cool, huh? Doesn't, okay, so any other question? Yeah, Celine?
What does that 1 say?
Where?
The 1 starting to be at under the
Digits. That's G right here. So the sum of the digits is divisible by 3, then the whole number is divisible by 3. So you see, you have 42, 4 plus 2. These are the digits, right? 4 plus 2 is 6. Does 3 go into 6? Yeah, that's why 42 is divisible by 6. Any question? Is there a rule for then 5? Does anybody know like whether or not a number will be divisible by 5? Is there a rule for that one? Yeah. Yeah, if a number ends with 0 or 5, you know for sure that 5 has to go into that number, right? Does that make sense? So those are the ones I think you should be aware of. The rules for 2, whether that number is even or not. Rules for 3, whether what? Sum of the digit is divisible by 3. What's rule for 5, class? If the number ends with 0 or 5. Does that make sense? I think those are the ones that... Other ones, you don't really need to know the other ones. Because, you know. Huh? 4, you don't really need for rule for 4 because if something is divisible by 4, guess what? It's got to be divisible by 2, you see?
By 2, 6, or...
Yeah, so you kind of... So don't worry about the other rules. That's the ones that... Rules for 2, 3, and 5 is the one important. We'll get there. Okay, so I want to give you some vocabulary that see if you... What is a prime number? Or sometimes we call it prime. Because we need to go over these before we get to some examples. So let's do some vocabulary work here. Judy, have you heard of prime number or prime? Do you know what that is? By multiply by 1 in itself, or what do you mean by almost? Like, give me an example. Give me an example of a prime number. 2. 2 is a prime number because it can only be not multiplied by, but it can only be, yes?
Factors can only be itself.
Yeah, the factors. In other words, it can only be divisible by 1 or itself, right? Very good. Now, so who could list? Okay, so who could tell me what I should write as my definition? How would I write a prime number as my definition? Can anybody guess what I wrote as the definition of a prime number? Emily?
A number in which the only factors are itself.
The number that's really close. Number where the factor of the number is only 1 and itself. Very good. I actually you have to add one more thing, because is 1 considered to be a prime number? Turns out, no, because so it has to be an integer greater than 1. Okay, and then rest what you said is correct. That has positive factor. Well, I kind of wrote it like positive integral factor, meaning positive integer factors. Okay, other than 1 in itself. Okay, so only numbers that has the factor that is 1 in itself that is greater than 1. It's got to be greater than 1. So 1 is not considered as a. Sorry, I froze that. Okay, so it's an integer greater than 1. Okay, that has no positive integral factor other than 1 in itself. Okay. So let's list these. So again, these are positive numbers. So what's the first prime number that we're going to start with? Yes, Thomas?
5?
No, not 5. Yes? 2. Sierra is correct. It's 2. Guess what the next one is? Derek? 3, sure. What about 4? No, 4 is not a prime number, is it? Because 4 is made up of 2 times 2. It's composite, 2 times 2. So guess what? Next number, yeah? 5. I mean,